Okay, in this video we'll talk about energy levels and sublevels. It was later shown that energy electrons occupy energy sublevels within each level, and the sublevels we give designations S, P, D and F. These designations are in reference to the sharp, principal, diffuse and fine lines in the emission spectra. The number of sublevels in each level is same as the number of the main energy level. So you can see the first energy level, it has 1s sublevel. The second energy level, it has a 2s and 2p sublevel. And the third energy level, you can see 3s, 3p and 3d sublevels. So you can find electrons in those sublevels. Now we'll talk about how many sublevels, how many electrons does it contain. Now when you see the maximum number of electrons in each energy sublevels depends on the sublevel. So when you see S sublevel, it holds maximum of 2 electrons. P sublevels holds a maximum of 6 electrons because P has 3 orbitals and each orbital contains 2 electrons. D sublevels holds a maximum of 10 electrons. D has 5 orbitals. And the F sublevel holds a maximum of 14 electrons. So the maximum electrons per level is obtained by adding the maximum number of the electrons in each sublevel. For example, level 1 has only one S sublevel, so maximum electrons contains 2 electrons. But level 2 has a 2s and 2p sublevels. So 2s contains maximum 2 and 2p contains 6, so total is 8 electrons. So that way you can add them and find out maximum number of electrons per level. Here you can see in this table, level 1 contains 1s sublevel and it has only maximum capacity is 2 electrons. So electrons per first energy sublevel is 2. Level 2 energy which has 2 sublevels, 2s and 2p. 2s maximum contain 2 electrons and 2p contains 6 electrons. When you add them, maximums are 8 electrons in 2 energy level. Energy level 3 contains 3s, 3p and 3d sublevels. And when you add those maximum electrons in each sublevels, you get 18 electrons in level 3. That's the maximum capacity in level 3. For energy level 4, it contains 4s, 4p, 4d and 4f. Again, S contains maximum 2 electrons, P 6 electrons, D 10 and F 14 maximum. And when we add 2 plus 6 plus 10 plus 14, you get 32 electrons. So that means energy level 4 contains 32 maximum electrons. Now, electronic configuration. So electrons are arranged about the nucleus in a regular manner. The first electron field the energy sublevel closest to the nucleus. And we know that energy sublevel first contains 1s, right? So electron continue filling each sublevel until it is full and then start filling next closest to sublevel. So the way order of increasing energy of those sublevel, you can see 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d and so forth. So when you start adding electrons, you can see 1s2, 2s2, 2p6 and then you can keep adding until you have that capacity done for that particular element. Here is a diagram where you can order does not strictly follow 1 2 3, but you can fill it out, predict the order of sublevel filling 1s, 2s, 2p, 3s, 3p, 4s, and that way you can go diagonally, and that's where you can fill it in electrons in those sublevels. Now when we write electronic configuration on a shorthand method, so first we need to find out the location of electrons by sublevels. The sublevel is written followed by subscript with number of electrons in the sublevel. For example, if 2p sublevel contains 2 electrons, then we can write 2p2. The electron sublevels are arranged according to increasing energy. So first, let's start with bromine. When you see in the periodic table, bromine has 35 atomic number. That means it has 35 protons and 35 electrons. Now we are going to organize energy sublevels according to increasing energy. We know that 1s comes first, 2s, 2p, 3s, 3p, 4s, 4d, and so on and so forth. And now we have 35 electrons. We are going to start adding 1s2, 2s2, 2p6. Out of 35, 10s are gone. Now we have 25 electrons left. Then we start filling 3s2, 3p6, 4s2, 3d10, 30 electrons gone, 5 electrons left, and then we can write 4p5. That's electronic configuration of bromine. So what is an orbital? So orbital is a region where there is a high probability of finding electrons. Alright. In quantum mechanical atom, orbitals are arranged according to their size and shape. And higher energy of an orbital, larger its size. You can see s orbitals have spherical shapes. 1s has smaller, 2s has little bigger, 3s has little bigger, and 4s you can see it's getting bigger. There are 3 different p sublevels. All p orbitals have dumbbell shapes. They are same shape, but it's oriented in a 3-dimensionally in 2px, 2py, and 2pz in different axes in a space. An analogy for electron in p orbital is like 2 bottles and the fly trapped in those 2 bottle, and you can see where it is located. That's where you can find electrons. The D-shaped orbitals have clover leaf shape. It's the dumbbell shapes, but it's the 4 dumbbells, donut shapes right here. And all 5 orbitals are organized in 5 different orientation. So in this chapter, we studied protons, neutrons, electrons. We studied location of protons, electrons, and neutrons. We defined atomic number, isotopes, mass number, atomic mass. We found light have both wave and particle properties. Particle of lights are referred to as photons. It's quantized. It goes to different energy sublevels. And that's about our chapter 4. We are done.